All right, so in this video, we are going to be talking about writing equations for situations, using variables for things we don't know. And then two, we're actually going to write multiple equations that are representing the same situation. And the way that that'll work is that they'll be equivalent equations. They will be equal. They'll say the same thing. And we're going to test to make sure that they're equivalent, show how to do that, okay? So in family B, the middle child is 5 years older than the youngest child. All right, this is kind of vague. We don't know much. We don't know how old the middle child is or how old the youngest child is, but that's kind of how it works, right? As time passes, one child might get older, or they'll both get older, right? There's just a 5 years difference between the two. So let's use an M to represent the middle child's age. And let's use a Y to represent the youngest child's age. So if I take the youngest child, what do I have to do to get to the middle child's age? Well, the middle child is 5 years older. So that means I'm going to add 5 years to get to the middle child's age. Okay, so that's one way we could represent their ages. If I start with the middle child, what do I do to their age to get to the younger child's age? If the middle child is 5 years older, then that means that if we subtract 5, we will get to the younger child's age. Right? Now, if I start with the middle child's age and I subtract the younger child's age, what will be the difference between their two ages? Remember, the difference is the answer to a subtraction problem. What's the difference between their two ages? 5 years. So these equations are all different. We have 1, 2, 3 equations. But logically, those all made sense as we wrote them. If we start with the younger child's age, or maybe we start with the middle child's age, or if we subtract the younger child's age from the middle child's age, what we get? They all made sense logically to us. So how do we tell mathematically that they're equal? We can tell because the solutions are going to be the same. So when we put in the younger child and the middle child's age, it will work for all of the equations. So let's test this out. If the younger child is 1 year old, the younger child is 1 year old, and we add 5, the middle child will be 6, right? Okay, so we've got the 1 year old and a 6 year old, right? Now let's see, are these equations equivalent? We will see because when we take the middle child's age, 6, and we subtract 5, oh, my pen didn't work on that last one, middle child's age 6, and we subtract 5, will it equal the same thing? Are they 6 and 1 in this equation too? Yeah, still works. Okay, so then last one, let's take the middle child's age. If the middle child is 6 and the younger child is 1, will it equal 5? Yeah, so the older child at 6 and the younger child at 1 makes all of these equations true. It has the same solutions. So we know that equations are equivalent when they have the same solutions. We know that equations are equivalent when they have the same solutions.